Hi, this is Mrs. Vance again, and we're beginning the notes now on Unit 2, which is Chemistry and Biology, and it's mostly based on information from Chapter 2 in your book, The Chemical Basis of Life. We're going to review some things. A lot of you have learned some of these things before in middle school, but there's probably a few new things that you need to learn about some of these topics. And so just bear with me, and if you already know this, that's great. Just skip through that part and continue on, because there are some things that you probably haven't had before. I'm going to ask that you read some pages in your book. Chapter 2, pages 26 through 29 will be a good start for you to get started on learning about chemistry and biology. So let's get started. First, we're going to talk about elements, atoms, and compounds. And I know you already know a lot of this stuff about protons, neutrons, electrons, that kind of stuff. I'm going to ask you to do a worksheet to kind of review some of that stuff, and it's going to be in your Schoology folder. But for the meantime, we're just going to talk about specifically about elements. We'll talk a little bit about the periodic table and mention a few things about protons, neutrons, electrons, but that's really just for review. Okay, so the big thing to remember is that organisms are composed of elements, and the elements are generally in compounds of one kind or another. There are about 25 elements that are essential for human life out of the 118 that are in the periodic table at the present time. 4 of those make up about 96% of your weight, and that's carbon, hydrogen, oxygen, and nitrogen. There are other ones called trace elements. We're not going to spend a whole lot of time talking about those at the present time, but we will talk about those 4 plus a few others extensively throughout the course of the year. Remember that a compound is a substance that is made of 2 or more different elements that are in a fixed ratio, and the fixed ratio is usually identified by the chemical formula. Something like H2O, CO2, and C6H12O6 are examples of compounds. And so that's the fixed ratio of those elements to each other in the molecules of that material, that compound. Okay. So big thing, first of all, number 1, we're going to talk about some of the elements. So I want you to look at the pictures here, and I want you to explain how table salt illustrates the themes of emergent properties when you look at the components of sodium chloride, or table salt. That is sodium, which is a soft metal, and chlorine, which is a green poisonous gas. Hopefully you recognize that when you look at sodium and chlorine, the properties of the sodium chloride compound that they form are much different than the individual properties of those elements. And so that shows our emergent properties, because when you put the things together, they perform a new function, or they have a new function in life, and that is as salt. Okay, so atoms, as you already know, are made of protons, neutrons, and electrons, and each element, of course, is composed of one kind of atom. And you should already know that the neutrons and protons are in the nucleus, and the electrons orbit around the nucleus. You've learned a little bit about energy levels, I believe, in middle school, so we'll refer to that a little bit as we go along. And you should already know also that the number of protons is the atom's atomic number, and that the mass is the sum of the protons and the neutrons that are found in the nucleus. Those are things you should already know. I'm just reviewing them because it's good to always review. All right. Here's a periodic table. This is the most recent iteration of the periodic table. Notice now that all 118 spots on the periodic table have been filled in. The colors down here at the bottom indicate the different types of elements that you find in the different periods. The periods are the columns or families are called these families, the alkaline metals, alkaline earth metals, and so forth. You'll learn a lot more about that in chemistry next year. The periods from the periodic table are the actual rows that you find on, and although there are similarities in the way the elements form compounds based on the families they belong to, the period also tells us how many energy levels they have. And so if you look here at the top, it's the number 1 period, that indicates that they have 1 energy level. That's hydrogen and helium. The second period shows that they have 2 energy levels. That includes those elements there, and so forth. And so we'll talk a little bit about that as we go along, but that just lets you know something about how many energy levels they have. Okay? So as we mentioned a minute ago, the atom's mass number is the sum of the protons and neutrons in the nucleus, and the mass is approximately equal to its mass number. Big thing to realize is the mass number that you see on the periodic table is an average of the most common isotopes. Isotopes of an element are atoms of the same element that have the same number of protons but different numbers of neutrons. And so the mass number that you see there on the periodic table, that might be 1.00576 or something like that, is going to be the average of the most common isotopes of that element. The table here at the bottom of the page shows that there are 3 different isotopes of carbon that are common. They all have 6 protons and they all have 6 electrons, but notice they have different numbers of neutrons, and that changes the mass. And we're going to do an activity based on isotopes, and so you'll be able to see how that works and see what that does. Some of those isotopes are going to be radioactive and are going to be unstable, and you'll see how that works when you do the gizmos activity. All right, another question. A nitrogen atom has 7 protons and its most common isotope has 7 neutrons. A radioactive isotope of nitrogen has 9 neutrons. So what would the atomic number and the mass number of this be of this radioactive nitrogen? So hopefully you got that the mass number of the radioactive nitrogen would be 7 plus 9, which is 16, rather than the 14 of the most common isotope of nitrogen. And that will complete the first set of notes for Unit 2.